Hi everyone and welcome back. In this video, I'm going to solve exercise 4-11, number 1 in the textbook Logic and Philosophy. So the goal here is to prove A after this statement, these two statements, A or the quantity B and C, and then the statement not C. Can we deduce A from this? So let's test that. So the first thing we should realize is that this statement A or parentheses B and C, that can actually be distributed out. So the rule is it would go A or B. So let me write that out. A or, let me do lowercase or, B parentheses, and so we preserve the or for the first distribution, and then and parentheses A or C. Right? And the rule that we use there is called distribution. So we distributed number 1. Right? That's typically how you write it out. We're telling you in that column H there, how do we justify the step? So let's just let's put some steps there just so we can do that. So if you have an AND statement, then you can take each piece of the AND statement. So let's just take this piece, A and C, or A or C. The reason why I say we should take this is because I see that we have a not C here. Okay, so A or C. Cool. Now, the reason we did that, that's called, what would that be called? Simplification? Pretty much, it's a conjunction rule. You can maybe put conjunction. Depends on the name that you use. Okay, now A or C. Now we know from step 2 that it's not C. So A or C, that means it's A. Right? And we know that from the law of disjunctions, I think you should say, or disjunctive, there's probably a word for it. Disjunction, and that's the using 2, and that's using 4. What is that called? All right. Either way, that's good enough. And now, look, A, we've proven it. That's the goal. The goal was to prove A, we've proven A. So the reason why this works is because we distributed this out and we got it done. There are many ways to do this, right? You could assume, I think probably the easiest way, at least the way I would approach it, if you have that toolkit available to you, is assume not A, and then you'd be able to get B and C, and from that you get C, and you'd show a contradiction with C and not C. But either way, this is using the rule of distribution. And I think that's probably the most straightforward way. That's the way that the book asked you to do it in this exercise. So if you got anything out of this video, just please like it. I'm going to go through and do some of these exercises, mostly because I find them interesting and I think they're kind of good exercise. And if you have any questions, drop a comment, let me know. But yeah, thanks so much for viewing. Bye.